Okay, so we are going to talk about what it takes to integrate trigonometric functions. So as we've learned, integrating is doing the reverse of differentiating or taking a derivative. So that's the way you want to think about it. What function would have a derivative of the thing that we're trying to integrate? Well, if we're integrating the cosine of x, um, the cosine of x is the derivative of sine of x. So the integral of cosine of x is going to be the sine of x. But we have to add plus c because we don't know what other term could possibly be there. Again, the derivative of sine is cosine. And the derivative of c is 0, so this makes sense. Now, what do we have to take the derivative of to get to sine of x? So that's why we're trying to find the integral of sine of x. Well, the derivative of cosine of x is negative sine x dx. So if this is negative, we have to somehow undo that when we find the integral of sine of x. So the integral of sine of x dx is actually negative cosine of x plus c. Because when we take the derivative of cosine, that is negative sine, and the negative sine times the negative gives us a positive sine of x. We have the integral of secant squared dx. So these are the main ones we're going to be using soon. We have to think, well, what do you take the derivative of to get to secant squared of x? Sorry, I dropped x here. Well, the derivative of tangent of x gives us secant squared. So therefore it follows that the integral of secant squared of x dx would be tangent of x. And of course, the plus c. Now, what if we had extra stuff, more than just an x, inside of all of our trig functions? Well, just like we had done before, we have to deal with those by dividing by the derivative of the inside. So, see if you can remember, what is the integral of cosine of x? The derivative, or the integral of cosine of x is the sine of that. So we have to keep the inside of our trig function the same. So it's the sine of ax plus b plus c, some number c. But because we have this part here, when we take the derivative of ax plus b, we are left with a. So since a is not present as a multiplier, as a coefficient of this term here, we have to then divide by it. Now you could write this as over a, or you could write 1 over a out front. Either way is okay, but we could leave it just like this. Same thing is going to apply for sine. So the integral of sine, if you remember from the last slide, is negative cosine. We have to keep the inside of the trig function the same. It never goes away. So we're left with ax plus b plus c. But because the derivative of the inside of this part is a, we have to divide by it. So making sure that we are accounting for the inside of other functions or further interior functions when we take our integrals is very, very important. And remember, you never, ever, ever drop the inside of trig functions when we are integrating or taking the derivative. It always stays the same forever and ever, unless it somehow happens to zero out at some point.